In this video we will start learning the assembly skill, and which is the ultimate goal of this lab. And assembly is basically a combination of different components. Most of the things that you see around you, they are basically assemblies of various components. For example, if I talk about a pen, so pen has an outer covering, it has a tip which is of different material, then it has ink inside it, and there are different other components like springs. And similarly, the chair that you are sitting on, the mobile phones that you are carrying, the laptops, mouse and keyboards and monitors, and most of the things that you are having around you, they are actually assemblies of various small components, and they are serving some sort of a purpose. So today we will be uh, trying to complete an assembly model of this pedestal bearing. As you can see in this figure, this is a type of bearing which is used to support shafts. If I open up this page in which there is a shaft, you can see in this figure, and it is supported by this bearing, and there are various other pictures like this is the practical application of this particular pedestal bearing. Coming back to this picture, so in this picture you can see this is the exploded view of pedestal bearing. Exploded means most of the components are now visible. So there are almost 1 2 3 4 5 6, there are a total of 6 different components which we will be creating first as solid part. And once all the solid parts are generated in CREO parametric, they will be combined to form an assembly. So all these components will be created first, and then they will be assembled. So the drawings are available. For example, this is the drawing. This is the front view of the main body, which is also called casting, and this is its top view. So using this front view and this top view, we can easily create this component. In a similar fashion, using the front view and top view of the cap, we will be creating the cap. And these are the dimensions of various other components. For example, there is a piston, there is a rod uh, which is having some dimensions. This 24 SQ means 24 by 24 square dimension. So it is a square at the bottom, and it has 24 units of length and 24 units of breadth. Then there is the dimensions of lock nuts. This is its front view, this is its top view. So diameters are given, the fillet radius are given, the thicknesses are given. Similarly, there is another type of nut which is having a different thickness. So these are the, using these dimensions, we will be creating these components first, and then we will be calling them into the assembly tool. Similarly, these are the dimensions of the brasses, so they can be very easily made. All the dimensions are very clear. Then this table here is called bill of materials, in which the total number of components are visible. For example, there is body, and its material is also given, which is of cast iron. And there is cap, brasses, square headed bolt, which is of mild steel, nut, then lock nut. So these are the dimensions and bill of materials of the said assembly. So what we do is we first create them. For example, I have created all the uh, pedestal bearing components. These are all the components. And once these components are created and saved, by changing the view we can even see them how they look like. So if I scroll to, so these are the components of pedestal bearing. So this is the body, this is the square headed bolt, this is the cap, this is brasses, lock nut, and the other type of nut. So we will be calling them into CREO parametric in order to complete the assembly. So uh, in this window we will be pressing this button, which is new. In this dialog box we will be selecting this assembly type of tool, and the subtype will be uh, the design, which is the default setting, and then we can set its name like pedestal bearing, and we also need to put some underscore here because it will not accept it, and using the default template we will be pressing OK, and this is how the assembly window looks like. So in order to call the components we will be pressing this button here, assemble, and then we will select the directory in which we have saved the components. For example, my components are all saved on the desktop in this folder CREO, and in the view I can even see them by selecting this thumbnail type of views. So the very first component that I will be calling is the body, the main body. So this is a very easy approach to call that component which is basic frame of the which is the main part of the assembly, and the rest of the features will be called after this. So select it and then press open. This over here is the 3D dragger. Using this dragger we can drag this part in these various directions. For example, this is currently Y direction, and this is X direction, this is Z direction. Similarly, we can also rotate them in any of the along any of the axis. For example, along X axis we can rotate them, along Y axis, and uh, along Z axis we can also rotate them like this. If I press Ctrl D, we will get back to the isometric view. So this is the base part, and for all the base parts we will set it to be default. So when we set it to be default, it will automatically be showing us the status of fully constrained, meaning this part is now coincident with the original coordinate system of this assembly drawing, and press OK. So this is now fixed, it is now fully constrained. Now we will be calling the other components. For example, using this same button we will be calling brasses, open. So brasses is now available on the screen. We will have to join them, we will have to join it on the main body. Sometimes this 3D dragger is disturbing. We can disable it by pressing this button over here, but if it is not producing some disturbances, then you just have to click it in order to make it visible. Then we will be trying to merge or trying to assemble this brasses over this body. How this surface, which is a cylindrical surface, if I select this surface and make it coincident with this cylinder, it will automatically go there, and the setting of coincident will be appearing. But the status is still partially constrained. We don't want the status of any component to be partially constrained. We want a fully constrained component. As you can see, it is partially constrained, so right now it can move along this direction. So in order to fix this direction, I will be selecting this face and coincide this face with this face. So now it is fully constrained. The status is shown, which is fully constrained. If I press OK, so the component is shown. I can change the display settings to shading with edges. So these two components are now assembled. I will call the third component, which is the cap. This here is the cap. If I press open, I can see this cap, and I have to make it coincide with this body. So this cylinder, select this cylinder, is coincident with this cylinder. As you can see, right now it is coinciding, but the status is still partially constrained, so we have to define other relations as well. Using this dragger, we can drag it to a suitable location, and then we will again make this surface and this surface coincident or centered, and then still it is partially constrained. So what we will do, we will select this face and this face and make them either coincident or having a distance of 0 units. If I press it to be 10, you can see it is directed in upward direction, and if I press it to be 0, it will be right on top of this main body, and you can see the status is fully constrained, and you press OK, and then you call another component, which is now the bolt, pedestal bearing bolt. Open the bolt and make this surface of the bolt, this surface, cylindrical surface, to coincide with this cylindrical surface. Control D, and still it is partially constrained because it can move along this cylinder. So what we will do, we will make this face and this face at the bottom to be either coincident or having some distance of 0 value. Now it is fully constrained and it is OK. Again we will be calling the same component because it is required over here as well, and this face needs to be coincident with this face, and it is fully constrained, and press OK, and then we will be calling the nuts. As you can see in this figure, the lock nut is at the bottom with number 6, and on the top of the lock nut there is a nut with more thickness. So first we have to call the lock nut, this here is the lock nut. Open, and this surface is coincident with this surface, it is partially constrained, and this surface needs to be coincident with the bottom of the lock nut. Now it is fully constrained. Press OK, and then again call lock nut. this surface is coincident with this surface, and this surface is coincident with this surface, so it is having a distance of 0 units. It is fully constrained. Press OK. Then we will be calling the final two components, which is actually the nut. This surface of the nut is coincident with this cylinder, and the top surface of the lock nut needs to be coincident with the bottom surface of the nut. Fully constrained status is shown. Press OK. Then you can call the same nut for the other side by coinciding this cylindrical surface with this cylindrical surface, and then moving it to some appropriate location and selecting this surface, and then select this surface, and the distance should be 0, and it is fully constrained, and press OK. So the assembly is now complete. I can give each component a different appearance using this appearance button. For example, if I want to give blue color to the base feature, this is the main body, press the blue icon over here, metallic blue, then select this main body and press OK. So the main body is now blue in color. Similarly, there can be other colors like yellow to the cap. Select the cap and press OK, and this maroon color to the brasses. Select the brasses and press OK, and the green color is for both these bolts. One bolt is selected. In order to select the second bolt, we have to press Ctrl first and then select this bolt and then release the control button. So both of these bolts are now selected. Now press OK, and then this brown color, wood color, or bronze, I will be selecting bronze color in order to color this lock nut, this one, and then press Ctrl to select the other lock nut and press OK. And copper color, polished brass, bronze, I will be selecting this polished brass color to be made for the nuts. Control D. So the assembly is now complete. In order to view the exploded view, in order to view each component in a segregated or separated form, I will be pressing this explode view. So each component is now separated, but its location is not appropriate, so I will be selecting it again to get it assembled. Then this button can change the position of exploded components. If I press it, then press this one, so when the assembly is exploded, the cap should be here, this nut should be somewhere over here, this nut should be here, this nut should be moved to this location. Similarly, this can be moved to this location. Brasses, I want brasses to be outside, like here, and nuts to be further below, like this. Select it, and like this. Similarly, this nut I want it to be further away, this nut to be further away, so that my entire cap is visible. Now press OK. If I press this exploded view, all the components are now assembled, and if I press it again, same components are exploded to the various locations which I set it. So that's all for the assembly of pedestal bearing.